Hello, I would just like to start off this week by giving a status report on our progress. As you guys recall, our last video, we mentioned how we had to test our code, which we had completed. We have actually tested all components, the RFID, the switch, the GPS and GPRS shield. As a concern that rise because of the test is we were having different baud rates causing problems within the code. So one solution was using the Arduino's library for serial ports, which simulates software ports. This was something that which we have not tested. However, in the process of that, Dylan was able to change the baud rate, which he'll talk about it later on in this video. And we'll do a test case of the code, which I completed right now with Ferran.
Okay. This is like a circuit that we have put together just to showcase what we have done so far. Just keep in mind that we don't have our GPS module or accelerometer, but here we got our Polaris switch, which turns on and off the W-lock, and it's a switching circuit that we designed and built that basically turns on and keeps it on only at the first RFID, and we're going to showcase the functionality later. Here's our battery, 2500 milliamp per hour, a rechargeable lithium-ion battery. Here's our charging circuit, which can charge and supply power at the same time. Here's our RFID tag, our microcontroller, and this is the GPRS shield, which transmits text messages via GSM. And here we're just going to showcase the functionality. So here's the correct RFID tag right now, and if we wave it in front of the RFID reader, it turns on the system, as you can see indicated by that LED light. So if you see now our Polaris switch, no matter how many times you press it, it's gonna stay on. It's because basically now the current is basically going to the BJT circuits, and it's still providing power to the Arduino. So, and if we do a second RFID swipe, it turns it off, and as you can see, the switch was turned off automatically. So the second RFID swipe turns off the system permanently. So, and this is completely off. And if we want to turn it on, there, it's just the RFID reader is on, and that's it. And if we want powered on again, first RFID swipe, there you go. And we just want to showcase one functionality of GPRS shield, where this is fully initialized, and as you can see, we survived the 800 milliamp to 1 amp current draw jump. So our battery can supply more around a 1 milliamp for a quick second. And now we want to showcase the GPRS code, which Dylan will present.
Okay, so the initial baud rate for the GPRS shield was 19,200. The other components that we're using in our system, like the GPS and RFID reader, are both set at 9600 baud as default. And in order to change those, we tried doing that, but like the command had to be sent every time, and it wasn't very reliable. However, with the GPRS shield, we could change the baud permanently by flashing the memory, because on the GPRS shield it has something called a SIM900 IC, and that has internal memory that we flashed to have, so it will update with the new baud of 9600. Initially, when I did that, I used the AT plus IPR command, and this was the output I was getting initially. Even so after I flashed it at 9600. What I kept doing, though, I kept alternating really quick between the original baud at 19,200 and 9600, while issuing a new command to basically reset itself. And eventually I kicked it out of that, and you can see here that right here it's saying that it's ready for more commands, and it's functional now. English and gibberish right there. So anyway, so that's how I was able to kick it out. This is a screenshot from earlier on my system, and this was the initial test code with the 9600 baud. Fast forward to now, we're able to actually send messages at 9600 baud, and actually get a response from that. So as you can see here, this was what I was getting initially with my code. you can see that it's not supposed to send all these commands. The message was repeated multiple times, and that's because it was still having a delay, thinking that the GPRS shield was set at 19,200 baud. So after changing the delay to reflect the slower baud rate, as you can see, I was able to actually get real messages without any gibberish. So now we should be back in business, and all of our components should be at 9,600 baud.
Thank you. So